Good evening, everyone. Welcome to the introduction class of data structures. In this class, we will see what is data structures, what is the overview, why you need to learn data structures, and where you're going to use it or how you're going to use it in your jobs. And basically, I'm going to be explaining this entire subject in detail from basics. So, if you are beginner, if you are just a student who are yet learning this, or whether you have already learned it or going to placements, this is going to be helpful to you. So let's start today's class. So throughout the class, if you have any doubts, you can use the chat box. You can ask for the doubts, and I will try to clear the doubts of all of you. I will try maximum to clear the doubts. If you have not yet subscribed to the channel, please subscribe and also press the notification icon so that whenever I make an announcement for the live class, you will get a notification immediately. And I have mentioned the group link for Telegram and our WhatsApp group. If you have not yet joined the groups, you can click on the links in the description and you can join the groups also. I will be sharing many handwritten notes in these channels, in these groups, so you can make use of them. And in our channel, we are going to have videos related to placements also from this topic. Okay. So now let's first start what is data structures. Okay, right. So what is data structure? So first, before that, we will see what is a programming language. So we all know what is programming language. I'm sure you would have learnt C programming, C++ or Java. Nowadays Java is included in school itself, so you would have learned certain programming languages. So data structure is not a programming language. Okay, so this is not programming language, it is a programming concept. So it's not a programming language. Data structures is a concept. It is a programming concept using which we arrange data. And we have learnt different programming languages, right? C, C++ and Java. Since it is a programming concept, it can be implemented using any programming languages. So data structures is a concept. Okay, is a programming concept which can be implemented using any programming language. Okay, which can be implemented. If you want, you can simultaneously take notes also. So if you are a student preparing for your exams, these notes are going to be very helpful. So try to make important points as well. So it's a programming language which can be implemented using any programming language like C, C++. Basically, C, C++ and Java are the popular programming languages that are used to implement data structures. And nowadays we have Python also. Python data structures using Python is also there. That is also becoming very popular nowadays. Here in our class, we are going to learn how to implement data structures using C programming. Okay, now I told you that it is not a programming language, right? I told you that it is a programming concept. So what is this programming concept is? Say you are going to build applications. So once you get into a job, a development job, you will be building applications, software applications, which serves various purpose. Like whatever application you create, data is a backbone of all those things, right? Everything handles data. So data is the raw information, and when you data is the raw thing that you collect, and once you arrange them and once you store it in a particular structure in a specific format, it becomes information, or we say processed data is information. So data is the raw format. Okay, so whatever you collect, so it is the raw format, whatever you have collected, that is data. And after processing or after storing it in a specific format, so it becomes information. Okay, so data processed in a specific format, processed or stored in a specific format, becomes information. Now what is data structure? So let us see the different examples of data. So what are the examples of data you can say is suppose you are building an application for student management system, or it can be a university, or it can be a college, or it can be a school management system, or you can build a management system for private institutes also, or you can have a application which manages all the operations of a bank, or you can develop an application which stores all the hospital, for a particular hospital it stores all the details of patients and the doctors and all those things. So let us see different applications. Okay, so understand this clearly, so you will know why data structures is important, or why are we learning it as a separate subject, why is arranging data in a specific format so important. Okay, so this example will give you what is the idea behind the subject. Okay, so different types of applications I am going to write now. So first is you can have a student management system, right? So student management system. So when we say student management system, it can be university or college, or you can have school. Okay, so this is one example. And then let us assume we have a employee management system. Okay, so what examples that I am giving is a very simple basic names, but whatever you're going to do is also mostly same, because other than real-time applications, even if you talk about Amazon, Flipkart, Myntra, this is all information. You have gathered lots of information and you're managing it, right? So the employee management system can be anything. It can be in a university where all the staff, the faculties, the teaching and non-teaching staff, those details can be managed. In a bank also you will have employee management and all those things. Okay, then let us assume bank application. Okay, so bank for banking application you are creating. In this banking application also you have two categories of people that you are going to store the details about. So one is about the customers, and then you might have the staff. Okay, again in university management system you can have students and then staff, something like that. And then these are all basically typically management system of people. And we might also have e-commerce based applications, right? So e-commerce based applications, like you have very advanced applications also. I am giving you very basic examples. So e-commerce applications, like you have your shopping websites, your Amazon, Flipkart, Myntra, whatever, all these shopping websites are there. Now we will see what is the frequency of data operations. So before this, we'll first see what all data operations that you can do. So what all operations you will have to do: insert new students details, insert new employee details, insert new customer details, staff details, and then you might insert new products, you might insert new vendors and customers. Okay, so basically you will have insertion, right? Insertion is one data operation, that is inserting a new record. Okay, and then you might have to delete existing record, that is also present, right? And then you might have to search for a given record, a particular record is there, you will have to search for it. And then you might have to sometimes arrange them also, sorting might be required. So basic operations are this: search, and then once you search you might even display. Now we will see which is the most frequently done operations in this case. Say for example, this is a student management system, right? In student management system we are going to store details of students. Do we have very frequent insertion of student details? No, it is only once per year, right? How frequently will you insert student data in the database? You are going to, when they are getting admitted every year, in the beginning of the academic year, you are going to store the student details. And deletion also once a year. That is, once you have joined now, this year you have joined in your college, and your data is inserted now, it will be deleted only after another 3 years or 4 years when you finish your course. And in this year, which all students' details will be deleted means these are the students who have just completed their graduation or post graduation, their details will be deleted. So insertion and deletion of new records happens once a year only, whereas searching for the student's record happens frequently, but again it is less frequent. Every day you don't have to search for the details of students. See, once you insert all the students details, you will have to maybe update the marks of the students once in a while, but you will delete the details only after they finish the program, and once in a while you are going to update the marks, and that is done for all the records at once. Okay, you're not going to do the updating only for 1 or 2 records. For all the records at once you're going to update. So that is in case of student management system. In case of employee management system, when will you insert an employee details? Rarely, only just 1 or 2 records when they join. Okay, very less frequency, right? It doesn't happen like an organization, it will not have new employees joining every day, and it will not have employees leaving the organization every day, right? It is very rare. So in employee management system, insertion of new data happens less frequently, deletion also happens less frequently, right? The frequency is less, and searching for employee management also is less only, not too frequent. So this is also less frequent only. Okay, and then in banking application, customers, you might have new customers every day. There might be banking apps you have, right? In apps, many people now you have instant account opening in just 1 minute, 2 minutes, like that. So customers might join very frequently, that is maybe every single day, so very frequent. And deletion less frequent. Searching might be required, okay, less frequent, or depending on the type of banking operations. So I think you basically got an idea. So this staff is similar to this employee management system. So this and this are going to be same. And in e-commerce application, so very instant, so millions, or it can be millions of very instant or very frequent and extremely in real time searching will be required in e-commerce applications. So a new vendor or a new user might join this Amazon, Flipkart apps every single minute, right? And many people might delete their accounts, and searching happens like millions of searches per minute might happen. So what are we talking about here is basically we have different types of applications, and in all the applications the operations, the data operations done are almost same. You have inserting new records, deleting existing records, searching for existing records, and along with insertion, see, you might have other things also, like you have updating records might also be present, okay, updating existing records. So these things are the basic data operations that you have. Now, which data structure you use depends on what is the frequency of these operations that are used. So do you need sorting or not? So that is all, that also matters. Okay, now this is about types of applications and types of data operations. Next, we will see why arranging data in a specific way is so important. So now we will see 2 types of data structures, and which one is beneficial for which type of applications. So types of data structures. The first one is static data structures. The first one is the linear data structure, linear structures, and non-linear structures. Okay, linear structures and non-linear structures. These are the two types of data structures. What are linear structures is the elements are arranged, or the data records are arranged in a list in a linear way. Okay, so data is arranged linearly. Okay, so arranged linearly. Here data is not arranged linearly. Data is not linear. Okay, so here how then what is this linear data structure? Which all things you will use for linear data structure is you will have lists basically. So you have arrays and linked lists. Okay, arrays and lists. And then here for implementation of non-linear data structure, we have trees, and we have different trees. In trees we have binary trees, and then we have B trees, we have AVL trees, then we have binary search trees. Binary search trees, these are special type of binary trees only used for searching. Okay, binary search trees, etc. You have many types. You have double A trees, you have splay trees, you have red black trees. So many types of trees are there. In our course we will learn almost everything. First I will be covering all the topics that are common for most of the university syllabus and also very common for placements, and in the end we will have the all the advanced concepts also. Okay, so these are linear data structures and these are non-linear data structures. Now how should we decide how to store our data structures, use linearly or non-linearly? It depends on the frequency of these operations that we are doing for a particular application. Say for example, student management system. Here data is inserted once a year, deletion is also done once a year, but searching, updating some marks, like you might have to update fees of a student, you might have to update marks of a student, so you will have to mark some attendance of a student. So these things require frequent access to the system. So when there is a frequent access to the system, if you are accessing all the data at once, say for example you are updating marks of student after a test. Now are you updating marks only for one or two students? No, you are updating marks for all the students. In such case, when all records are accessed every time and insertion and deletion is very less frequent, then linear data structures are used. So these are simplest to implement. Okay, so these are simple to implement. So we will use linear data structures whenever insertion and deletion doesn't happen every now and then, and it happens very rarely, or it happens in a specific period of time only. And if you are updating any information, then you are updating all the information. That is, for all records you are updating the marks, for all records you are updating attendance. Okay, so whatever modification you are doing, you're not doing it for specific element. Basically you don't have to search for one specific student's details. If you do it also, it is not very frequent, less frequent it is, like once in a while you might have to search for one specific student's details. Okay, so that is so we will use linear data structure for student management system. Okay, so this is going to be linear structure, right? Next, employee management system. Employee management system also, the insertion deletion happens very rarely, and once salary is processed every month for all the employees at once, you're going to process the salary, you're going to update the leave status, you're going to update if there are any cancellations, if there are any deductions that is to be done, all that will be done at once for all the records. So for that also you can use linear structures only. Okay, so banking application. Here also when I said employee management system, it is same for staff. So staff data can be arranged linearly. Now When it comes to customers, that is real-time applications, basically anything that gets updated real time, that is the number of customers that a bank has, and the e-commerce application. The best example is this e-commerce application. And then you have this booking websites, no, you have ticket booking, movie booking, and then you have railway reservations or flight booking. All these things also, they're all real-time applications. You can have new users joining from multiple locations, and there might be people who are deleting their accounts, booking multiple people, booking some flights and all that. So whenever there is such real-time applications which requires very fast access, so all the operations are done very frequently, and most of the operations are searching. Basically, see, you go to my makemytrip.com and you search all the flights that are available, right? So you're going to give some criteria there, date and from and to place, and it's going to give you a list of flights that are available as per your search key elements. So here searching is more, right? So in such cases, you want the results to be displayed very fast. You don't want to you don't want to search for a record from the beginning to the end. You will want to reduce the amount of time or amount of iterations, loops taken to search for the required record. So you will make use of non-linear structures like trees. Okay, so here whichever is real-time applications requires non-linear type of data storage. Understood? So what is linear and non-linear? In linear, elements are stored in a linear way, in a list. You cannot access directly a specific element. So if you want to search for an element, you have to search all the elements from the beginning to the end. In some cases, indexing might be present, but still you will have to require all the elements from beginning till end. You will have to search. In non-linear structures, you have some data that are divided into groups or levels. In this case, the searching or inserting will be very fast. So, but which one you will have to implement? So this is difficult to implement. Difficult or complicated to implement. So which one will you choose to implement, whether you will use linear data structures or non-linear? It depends on the type of application that you are developing. Now, when you have say 10 records or 20 records, literally it doesn't matter whether you are storing it linearly or whether you are storing it in the form of a tree. But when you have millions of records, then it definitely becomes so important. The arrangement will enhance the performance of your application in a great way. Okay, so let us see an example. Suppose you have a list of elements. Okay, so you have a list of elements, and let us not consider a very small list. Let us take, we have 10,000 records, or maybe some student record or something. So let us assume I have records from, arrays will start from 0. So I'll take from 0 only, and up to 999 I am writing. So I have 1000 records. In this 1000 records, I want details of a particular student, and let me assume that this list is not sorted. It is not sorted in ascending or descending order. Randomly, as and when I get student admissions, I have kept on storing the details one by one. Okay, right now I want to search for a particular student's details. Now, what are the possibilities? The possibility, what is the best case? What is the best case? The required student details, okay, required student is the first record. Okay, that is the best case, isn't it? Now, my required students details itself is a first student. So as soon as I get the students details, I am not further searching. I will break the loop and I will come out of the loop and I will display the students details. So this is the best case search results. So when I want to search for a required record, the best case is that the first record that I am choosing itself is the required record. Required student is the first record. This is my best case. So what is the worst case? Worst case is required student is in thousandth record. Required student's record is the thousandth record. That is this one, okay, thousandth record, or not found. After doing this thousandth search, right, after doing this search comparison for the thousandth time, here if you find, then that is worst case, or here if it is not same, then that is also worst case, means student is not present in the list. Maybe the student has left the college or institute, or maybe the student number that you have given is wrong. Okay, so if you have given a wrong register number to search also, it will say that the student enrollment number or student registration number is not found. But when will it decide, when will your program decide that it is not found? Only after the thousandth search. So this is my worst case. So basically, if I have 10,000 students, then what is my worst case? That the required student is the 10,000th record, or it is not found. But best case doesn't change, isn't it? So when we are writing algorithms, what we have to search is which is the best case, which is the worst case. So we never consider the best case scenario. We always consider the average case or the worst case scenario. So this is called as analysis of algorithm. So when you implement an algorithm, you are going to first consider what is the worst case scenario of that particular algorithm with respect to this data structure. Okay, the same worst case is less in case of tree structure. Now let me assume I have a tree structure. Okay, instead of this type of implementation, I have implemented a tree. As per tree, I am going to store the details like this. Okay, this is an example of a binary search tree. So like this, we have the elements stored. Here every circle denotes one student record. Okay. So this is an example for binary search tree. So let me assume all the data here are in a specific order. So when we learn binary search tree, we'll understand it better. So here I am dividing the records in two equal half. So if I have 1000 records, then 0 to 500, sorry, 1 to 500, the students' details will be this side. Okay, and let me assume this is the 501th student. Okay, and then 502 to 1000 records is going to be to the right side. So here the records are divided into two equal half, and further among this 1 to 500 also, here I am having 250th record, and to the left of 250th record I will have 1 to 249, and towards the right I am going to have from 251 to 500. So basically here I am not having a linear structure. So I have not arranged all the 1000 elements one after the other. Instead, I have arranged it in this form, in a non-linear way. So now if I want to search for a student's details, then directly I am going to search this one first. When I search this one, I will know immediately whether the student's detail is present to the left side or to the right side. If the required registration number is less than this record, then I will directly search it in the left side. If it is greater than this record, then I will search it to the right side. So basically here I am not searching every single record. So my worst case scenario, which is this particular element, which is the last element, I will reach in very few loops compared to the previous one, compared to the linear structure. Here worst case scenario is basically, it is called log of n. So we will see, and you will actually have analysis of algorithms as a separate topic. So I will take up analysis of algorithms class maybe after a month, but right now we will not consider, we will not get into the details of those worst case and best case measures, but you will have to just understand how to choose a particular structure and how to choose a particular implementation. It is completely based on the type of application that you are creating and the frequency of the data operations that is done with respect to your application. Okay, so in this case, worst case scenario will be reduced a lot. So that is called as best case and worst case scenarios. We have those things that will be covered in a separate subject. Okay, fine. So this is about data structure types. So what is a data structure? It is a programming concept, not a programming language. It is a way or the structure, the arrangement of data that gives a structure to it. Why is arrangement so important? Because when we are building real-time applications, the way we have arranged the data implement by a great extent how fast your applications work. So this structure is going to affect it greatly. So before we store any data in a particular way, you have to first analyze all these operations, what all operations, data operations are done with the data of this particular application, and which type of arrangement is best, so that the search results, the updating and all that will take less time. Okay, and in a particular application you might have two types of data also, like here I have mentioned. In this application you have two types of data, and for one customers we have arranged non-linearly, and for staff data is arranged linearly. That is also possible. Okay, now these are types of data structure. Next is types of implementation. Types of implementation of these data structures. So we have two types of implementation. If you have attended my C programming class, you will very well know two types of implementation. So one is the static implementation and the other one is the dynamic implementation. So static implementation is where we make use of arrays. Okay, and in dynamic implementation we will use pointers and dynamic memory allocation. In both these things we will be using structures. Okay, structures are common because you know that we are not storing one single number, isn't it? We are storing one entire record, like the application examples that I gave you, student management, banking application, e-commerce and all that. Every detail you will have, every record has so many things. A student has so many details to be stored. If it is an e-commerce application, one product will have so many details that is stored about it. So we are not going to store single numbers here. We will be storing a full record, right? Therefore we will have to use structures. Structures is compulsory, and this structure, if you are creating array of elements for this structure, then that is called as static implementation. If you are creating pointers for these structures, and if you use memory allocation functions, that is dynamic memory allocation, like malloc, calloc and all that, then it is called as dynamic implementation. For this you will make use of pointers. Now most of you already know the advantages and disadvantages between arrays and pointers. The same thing holds here also for implementation. So what are the advantages here? So this is very simple to implement. Okay, simple to implement, and this is difficult to implement, or you can say, instead of I wouldn't like to use the word difficult, instead I will say it is little more complex. So complex to implement. This is the advantage for static implementation. And what are the disadvantages? So if you say for static implementation is memory allocation is fixed, right? So memory is fixed, that is the size is fixed basically. The number of elements that you can store is fixed. You have already done programs using arrays. If you have declared an array with 10 elements, you cannot increase, you cannot store more than 10 elements, and you cannot, if you are storing more than 10 elements, it's not possible. And if you store very less elements, then lot of memory is wasted. And suppose you delete some in between element, because we did not have deleting. earlier. Suppose you delete some in between element, then you are creating an empty space there, isn't it? So you have data all over, all these data is present. Now here suppose you are deleting one of them, okay, only this element if you are deleting, then or you are creating an empty space here, and you will have to shift all these elements one position to the left in order to fill this empty space. So whenever you are deleting a record in an array, it involves lot of data movement. So this all are disadvantages of arrays. Okay, so basically memory size is fixed, therefore if you are storing less elements, memory is wasted and you cannot store more elements, and when you delete certain elements, lot of data movement is required. Okay, whereas here memory is allotted as and when required. Using dynamic memory allocation, we can allocate memory whenever required. Whenever we don't need, we can release the memory also. Okay, and deleting operations. So if you want to delete, then delete operation involves lot of data movement. Okay, data has to be moved. So what is data movement? Basically you will have to copy so many records. Okay, and here delete operation requires adjustment of just one or two pointers. Okay, adjustment of one or two pointers, that's it. Okay, and see, understand, these are types of implementation. So here I told you different types of data structures. You have arrays, linked lists, both are linear data structures. So this is basically static implementation. Okay, and linear data structure, if you have dynamic implementation of linear data structure, is linked lists. Okay, and in non-linear data structure, I told you that we have binary trees, B trees, AVL trees and all this. Each and everything can be implemented statically and also dynamically. Okay, so in our class, in our upcoming classes, we are first going to learn static implementation of certain elements. Okay, we are going to learn, we have different structures. Again, we have specific structures like stacks, queues, lists. So when it comes to lists, actually I should have written here stacks. Okay, stacks, queues and linked lists. Stacks, queues and lists. Okay, and everything can be arranged in everything can be implemented in static also, dynamic way also. Okay, so what are we going to learn in the upcoming classes? And before we start writing programs, there are certain things that you will have to learn also. So let me give you a brief overview of what all things we are going to learn in the upcoming classes. So basically under linear structures, linear data structures, you are going to learn stacks. Okay, then you will learn queue, and then you will learn lists. Both these you will learn static implementation also, dynamic implementation also. Okay, means you will learn how to implement stacks using arrays and how to implement stacks using pointers. Okay, so what is static implementation? Basically it is usage of arrays with structures, and dynamic implementation is the usage of pointers with structures. For both of the things you will need structures. Okay, again queues also we have static and dynamic, and lists also we have static and dynamic. Okay, and dynamic lists are also called as linked lists. Okay, that is in linear data structure. And in non-linear data structures, we will first learn binary search tree. Okay, binary tree, and then we will learn binary search tree, and then we will learn B trees. Okay, AVL trees, also called height balanced trees, we will learn. And then we will see an introduction to red black trees and splay trees. Okay, red black trees and splay trees, we will just see an introduction to it, not much of a detail. And all these things we will mostly be using dynamic implementation only. Using arrays to implement this is extremely confusing, so we will not try to implement these structures, this nonlinear data structures using arrays. We will be using pointers with structures only. In case you are preparing for your exams, if you are a student still preparing for your exams, then if you put that in a comment. If you have a specific program in your lab manual which you want me to solve, you can mention that, so that we will solve only that specific question. But if you are preparing for placements, they will definitely not ask static implementation of nonlinear data structure. That is the worst complex thing to do, which none of the companies will ask you in a interview. In interviews, you will have stacks, queues and lists only. You will have both the static and dynamic implementation questions you will have. Then they only will ask you about theoretical concepts under binary tree, binary search tree and all that. Very rarely they might ask you the coding part of it, and if they ask you, it is definitely going to be dynamic implementation only, not static implementation. Okay, so this is what we are going to be learning in our upcoming classes. One by one we will start learning all these concepts. And before we start writing actual programs in data structures, there are certain things which you have to be very thorough with when it comes to of C programming concepts. So what are the topics under C that you will have to be thoroughly knowing is that you need to know about functions. Okay, arrays anyways you will know. Let me write that also. So please go through your arrays knowledge, and then see what is a function, how to implement a function and all that you have to practice. And then learn how to declare a structure, how to access elements of a structure, and then you must learn pointers. These 4 things are compulsory. You must learn all these things. So try to learn the programs in which how to access elements of structure using pointers and using dot operator and all that. These things you have to learn. In case you are not, your knowledge is not very thorough in terms of these things, I will also mention the links for these videos in the description. Please go through that and practice it very well. Otherwise you will not be able to understand data structure programs, because these programs are going to be very lengthy. Okay, please let me know if you have any questions. I will reply to you in the chat section. So if you have any doubts, any clarifications, any questions, please let me know in the chat section. I will also be live streaming the classes for C programming. So if you know it very well, fine. Otherwise you can go through those things also. For these functions, pointers and all that, you can even go through those videos in order to get an in-depth knowledge of programming, so that data structures will become very easy for you. Yes, please let me know if you have any clarifications, so I can answer your questions. As I have mentioned before, I have mentioned the links for the WhatsApp group, Telegram channel in the description. Okay, you can join those groups, and we will be posting some handwritten notes and all that in those channels, so it will be helpful. Further to add to this, if you have, like I told you earlier, if you have any specific programs in your lab manual, or if you have already started preparing for placements, and if you have started attending interviews also, technical interviews, and if there is some question which you are not able to solve, you can post that question also in the comment section, so that I will record a video for that separately, and I will be posting it in the channel. If you have not yet subscribed, subscribe to the channel and use that notification, that bell icon. Otherwise, sometimes you might miss the class updates. So as soon as I create a link, you will be notified if you have subscribed. And if you have friends in your other classes, please share these links with them as well. Okay, any further clarifications? Any clarifications? Okay, anyways, if you have any clarifications, please mention in the comment section. Okay, so this is about the overall overview of what is the subject, what all things you will be learning, why is this important, okay, types, implementations, all these things are learned. This will definitely be your first chapter in your syllabus, overview of data structures. So the next class will be updated in the channel, and also I will be posting the links in the groups that I have mentioned. So keep watching, keep sharing, and see you in the next class. Bye bye.